I'm David DeLon, I'm a BlueStamp engineer. I go to Ramada School. I'm a rising senior, and I built the digital stethoscope. So basically, this is the main part of the project, at least the hardware part. So this part is basically what this is the amplifier. So this is the microphone inside of the digital head, stethoscope head, which connects to a series of resistors and capacitors, which goes through an op-amp, which amplifies the signal, the voltage signal, to get a larger reading, because the microphone has a very small output. So this is the 5-volt connector, and the output from the op-amp goes straight to the microcontroller, and the microcontroller takes the data that it's receiving and it outputs through serial, which in turn goes to MATLAB, and I'll show you the MATLAB. And basically all the rest of that we didn't use. It was like flashes. So I'm running this in MATLAB, which is a standard program, and as you can see here, stethoscope output. Here this says, if you can't read it, output voltage, and here's times per second, and here's a BPM indicator, which I'll talk about in a second. So right now it's indicating that it's coming at 2.5 because of the amplifier circuits. It's amplified the signal. So right now it's flat basically. As you can see, it's the line coming back and forth. The only thing you can really see here is noise. You can see that right there. There's little bumps. But that's basically it. So let's say I actually if I turn the head over, the microphone is right here. But let's say I hit it, since right now it's flat. So if you hit it, then you get a result. Basically it's converting the hit into voltage. So when you hit it, the voltage is changing because it's not at equilibrium anymore. So you can hit it, you can see that. The problem I've been having right now is that when I hold it to a heartbeat, it's not as strong as when you just hit it like that. It won't go from 0 to 5 volts. I'll show you right now. It'll stay very steady, and it won't oscillate as much. So let me just put it against my neck. So see, I'm moving the head right now, and it's creating changes because the microphone is picking up noise from when I'm lifting it up. So you see those spikes that I had just now? That was my heartbeat. And you can see the BPM at the bottom is changing based on what the rate is. So I admit that it's not exact because there was only 30 seconds there where I was actually using my heartbeat, and the rest of it was like either noise or moving it around or tapping it. It's not exactly picking up my BPM, but it's around that number. So let me try showing you if I talk right now while I'm holding it up to my neck. Let me just get the right place again. So if I talk now, you can see that it oscillates a lot more just because I'm talking instead of just having my heartbeat. So you can see when I make high noises, the voltage changes tremendously. So let me just make some screeches. Ow! 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 See, those points have greater voltage changes because noise is so radical. So if I do it again, ow! Ow! You can see that. So that's my digital stethoscope, and I hope you enjoyed it. So that was my digital stethoscope, as you saw in the other room. So my favorite part of the program was like the individualism that you have and just get like the final result the way that you imagined it. My favorite part of my project personally was getting it to work. That was a very nice part considering that it took me so long. It's the last day, and I just got working today. Most challenging part. Well, for me, probably getting the program to work was pretty challenging because we didn't really know how to work. Like it was made for someone else's code, and we had to just cut out like a ton of stuff, so it didn't compile for like 2 weeks. And lastly, next step, probably add like a blood pressure monitor or a pulse oximeter.